In this video, we'll be looking at the law of conservation of mass, and it follows on from the video on chemical reactions. Before we start, this reaction was talked about in the last video, and it's the chemical reaction that is used to produce the class model volcano, where the bubbling foam comes out the top. Now, the law of conservation of mass is that the total mass of reactants, so if you recall, the reactants are the things that react together, or the starting materials, must equal the mass of the products, so what we end up with at the end. And if you recall from the last video, we have our reactants here. It's vinegar and baking soda. It's an arrow in between the two sides because these are not equal. They don't end up being the same thing. They produce, or they turn into, the products, which are salt, water, and carbon dioxide. But the law of conservation of mass, where it talks about the total mass of the reactants or starting materials must equal the mass of the products, what we're looking at here is the actual atoms that make up the molecules. Things don't just disappear in a chemical reaction. In this reaction, you have vinegar, which is acetic acid, so it's C2H4O2, so you've got 2 carbons, you've got 4 hydrogens, sorry. Now the hydrogens, the fourth one's around the back here, so you've got 1, 2, 3, and there's one around there, and you've got 2 oxygens. And then it reacts with baking soda, which is sodium bicarbonate, so you've got 1 sodium here, a hydrogen, a carbon, and you have 3 oxygens. And they react with each other to produce sodium acetate, water, and carbon dioxide as the products. Now, in terms of the law of conservation of mass, things have not just disappeared or just come into being. So when I have a look at my actual atoms that are in these molecules, so this molecule's a compound because it's made up of different atoms, I have 2 carbons, and in my sodium bicarbonate I have 1 carbon. So on this side, my reactants, I have 3 carbons. Over here I have 2 carbons are in my sodium acetate and 1 is in my carbon dioxide, so I have 3 carbons. I have 4 hydrogens in this molecule and I have 1 hydrogen in this molecule, so that's 5 hydrogens. Here I have 3 hydrogens and 2 hydrogens, that's 5. So again, I've now gone from having 4 and 1 to this molecule has 3 and this one has 2. But the hydrogens still all exist in my products. I have 2 oxygens in this molecule. There's 3 oxygens in sodium bicarbonate. In my products, I have 2 oxygens, 1 that's 3, and 2 that's 5. Another example we can look at is when I have copper carbonate and it is heated up. So when it's a solid and it gets heated up in a Bunsen burner in a flame, the copper carbonate reacts to produce copper oxide and carbon dioxide. So the copper oxide is still a solid and the carbon dioxide is a gas. And again, when you stop and you look in terms of being a balanced equation and looking at the law of conservation of mass, I have 1 copper here. In my products, I have 1 copper. There's 3 oxygens, and in my product, there's 1, 2, 3 oxygens, 1 carbon, 1 carbon. So in terms of the law of conservation of mass, what I started with in terms of atoms is what I end with in terms of atoms. Now, if I was actually to have weigh and get the mass of my copper carbonate, when it's reacted, I end up with copper oxide, which I could also weigh and get the mass. Now, the mass is actually going to be less. That doesn't mean stuff has disappeared. What's happened is carbon dioxide gas has been released into the atmosphere. So if I haven't done it in some sort of container where I can capture the gas is going to escape into the atmosphere. It still exists though. So in terms of the law of conservation of mass, what I have begun with in terms of atoms, I have at the end. Now there's some videos below here where I would like you to write your own description of the law of conservation of mass, and you could include some different examples than I've used above. So there's 2 videos here which are very, very clear, and then this is getting up into a little bit of a higher level video on the law of conservation of mass, and I have also included a website link here. So again, I would like you to write your own description of the law of conservation of mass and include a couple of examples, that would be great.